right, physical science students, we are looking at matter. Just to remind you, matter is anything that, what? If you said has mass and takes up space, you are correct. We are now going to look at the smallest units of matter, and those are things called atoms. When we have a sample of atoms that all have the same identity, we call that an element. All right, so let's look in depth at atoms here. There are two main components of an atom. The first main component of the atom is its nucleus. Inside the nucleus live a couple of subatomic particles that you need to know. There are other things as well, but these are the main ones that I want you to know for this class. The first subatomic particle is a proton. A proton is a positively charged particle with a mass of 1 AMU. AMU means atomic mass unit. Protons are important in atoms. They determine the identity of atoms. So how many ever protons are contained in the nucleus of an atom tells you what kind of atom you have. And I'll give you an example. You're going to be working with a periodic table soon, but just from the periodic table. For instance, carbon has 6 protons in the nucleus. We know that any atom containing 6 protons is carbon, okay? Carbon's an important one for life here on this planet. All right, the other subatomic particle that lives in the nucleus are neutrons. Neutrons, as the name implies, has a neutral charge and a mass also of 1 AMU. So almost the same as a proton, and neutron's a little bit bigger than a proton. And neutrons have an important function in the nucleus as well. As we just said, protons are all positively charged. Okay? And you should know a little bit about charges, electrical charges. What do like charges want to do? Do they want to get together, or do they want to repel from each other? If you said repel from each other, you are correct. Just like ends of a magnet push each other away. Well, like charges also push each other away. And protons are all positively charged. So if you have a bunch of protons hanging out in your nucleus, for instance, uranium is an element that contains 92 protons in its nucleus. All those protons are kind of wanting to get away from each other because they're all the same charge. So we believe that that's the point of the neutrons. The neutrons are in there to stabilize that nucleus so we don't have a bunch of elemental atoms splitting up because the protons are getting away from each other. So the neutrons are in there to make that a little more stable situation. And we find that the higher the number of protons, the more and more neutrons are contained in that nucleus to stabilize it. All right, so that's the nucleus. That's the first main component of an atom. The second main component of an atom is something called an electron cloud. In order to understand that, you have to know what an electron is. An electron, and hereafter we'll abbreviate an electron, small letter e, with a negative superscript there, because electrons aren't negatively charged. The mass of an electron is just about 0 compared to protons and neutrons. Electrons have hardly any mass. So we say essentially it's 0. Okay, so this is where the electron cloud is where electrons live. What is the cloud? Well, the cloud is the area where an electron is most likely to be found. And why do we say it so ambiguously like that? Thanks for asking. We say it that way because we cannot determine the exact location of an electron. The best microscope that we have to see things that are really, really, really small, and atoms are really, really, really small, is a scanning electron microscope. And that microscope shoots a beam of electrons at the object you're trying to see. And what did we just say about like charges? What's going to happen when we shoot a whole beam of negatively charged electrons at an electron? What's it going to do? If you said it's going to jump away from that beam of electrons, you were right. So every time we go to try to see where an electron is, the electron moves. So we cannot say for certain where any electron is. What we say is we have this electron cloud, and we say that within that area, within that space, is the space where electrons are likely to be.